right, so now let's graph this one. All right, so we're going to graph y equals x minus 1 times x plus 2 times x plus 3. This is already in factored form, which means to find our x-intercepts, we just merely need to set the factors equal to 0. So x minus 1 equals 0, x equals 1. It'll be 1 x-intercept. If x plus 2 equals 0, then x is negative 2. And if x plus 3 equals 0, then x is negative 3. And we can even go ahead and graph those. Graph it in a different color. 1, 0, negative 2, 0, and negative 3, 0. If I can get those. There we go. All right, so now let's find the y-intercept. All right, so to find the y-intercept, well, x is always 0 on the y-axis. So to find the y-intercept, just plug in 0 for x. So we have 0 minus 1 times 0 plus 2 times 0 plus 3. And that gives us negative 1 times 2 times 3, or negative 6. So we can go ahead and graph that one. I think my orientation's a bit off. There we go. Keep missing my point. All right, so now we need to know what happens in between those points. And to do that, we need a sign chart. That'll tell us whether our graph is above or below the x-axis. And we can also use that to approximate relative extrema. All right, so our intervals are determined by our x-intercepts. So we have where x, our smallest, is negative 3. So we have where x is less than negative 3. Oops. Sorry about that. I accidentally wrote my sign the other way. There we go. We need where x is between negative 3 and negative 2. And then we need where x is between negative 2 and 1. And then where x is greater than 1. All right, and how we find out the sign and approximate extrema is we're going to plug in values on all those intervals. All right, so for x is less than negative 3, plug in anything less than negative 3. You may as well plug in the smallest thing, which would be negative 4. So this will be our first one. All right, so y equals negative 4 minus 1 times negative 4 plus 2 times negative 4 plus 3. And that's going to give us negative 5 times negative 2, and then times negative 1. So that's going to be negative 10. All right, so for values of x below, that are less than negative 3, our graph is below the x-axis. That won't be an extrema point because our extrema occur between the x-intercepts. So that means our extrema are going to occur here and here, between negative 3 and negative 2, and negative 2 and 1. So let's plug in a value in between negative 3 and negative 2. We really don't have a whole lot of choices. It's going to be a fraction. Let's choose the halfway point. That's the most likely candidate. Anyway, for an extrema point would be just the halfway point when you've got no integers here. And the best we can do is approximate our extremas. All right, so let's plug in negative, so that would be negative 5.5 or negative 2.5, however you want to write it. So negative 2.5 minus 1. And I just tend to do better with fractions. So I'm just going to put, I got to change 1 into 2 halves. And then we have negative 5 halves plus 2, and 2 is 4 halves. And then we have negative 5 halves plus 3. And 3 would be 6 halves. just a little easier for me to do the multiplication with the fractions and the decimals. So negative 5 halves minus 7 halves, that minus 2 halves is minus 7 halves, negative 7 halves. Negative 5 halves plus 4 halves is negative 1 half. And negative 5 halves plus 6 halves is a half. So I can multiply that pretty easily. Right? In the numerator, that's a positive 7. And the denominator, that is a positive 8, right? So negative 7 times negative 1 times 1. Let me move that up just a little bit so you can see that better. Oops, too high. There, now I think you can see that better. So negative 7 halves times negative 1 half times 1 half, that's just going to be a positive 7 and over 8. So that is above the x-axis, so we are positive here. And this is going, whoops, hit the extended page. That is going to be one of our relative extremas. All right, so that would be a relative max because it's positive. So let's label that relative max. All right, we still have 2 more intervals. All right, so now let's plug in our third interval. Is going to be between negative 2 and 1. All right, so we already know one value, right? We know that what the value of y is when x is 0, right? That was negative 6. So we do know this is going to be negative. But is negative 6 our most extreme value? Since we have another integer there, let's just go ahead and check out negative 1 as well. So negative 4 minus 1 times, negative 1 minus 1, to make sure I look back at my equation, negative 1 plus 2, so I'm just plugging back into our equation right there, and negative 1 plus 3. Is it more extreme than 0? So this gives me negative 2, 1, and 2, and no, it is not more extreme. So our relative minimum there is going to be right here. Our y-intercept is also a relative min. That's all of our relative extreme values because we just have 3 x-intercepts, so that means we can have 1 between each pair. So 2 is the most extreme as we can have. But now let's just check and find out what happens to our function when x is greater than 1. Now, we only have, each of our x-intercepts only appears once, so we are expecting to cross. So I am expecting a positive value, but let's double check. All right, so our last one to plug in there is a value greater than 1. Let's choose 2. 2 minus 1 times 2 plus 2 times 2 plus 3. All right, and that's going to give us 1 times 4 times 5. That'll be 20. So yes, indeed, it is positive. Let's go ahead and graph now our extreme values. And we're almost done. All right, so we have a relative maximum at negative 2.578, so right here, if I can get it in there. Halfway there and almost to 1, but not quite. And then we have our relative minimum is already in there. The other 2 points, the ones on the other sides of the x-intercepts, are optional points to graph. If they fit on the graph and they're not too difficult to graph, go ahead and graph them. No reason we shouldn't graph maybe the, we plugged in negative 4 and we got negative 10. We can graph that one. All right, so that can just help us a little bit. We know that at values less than -3, it's negative, so we expect to be below the x-axis. Right? So for values less than -3, we're going to be below the x-axis. For values between -3 and 2, we're going to be above the x-axis. And then for values, my shadow is blocking. For all the other values between, but it's hard to talk and draw at the same time. For values between -2 and 1, we're going to be below the x-axis. But remember, 1, 2, 3, 4, 5, 6. Remember, this is a turning point, so remember to turn here. How do we know it's and we're going to keep crossing. How do we know it's a turning point? Because you have to turn around, right, to get to the next intercept. Your turning points occur between your x-intercepts, right, and our most extreme turning point, most extreme value was the -6. So that's going to be our relative minimum. When you're in calculus, you'll be able to calculate the exact turning points. Here we will approximate. Right? It's probably very close to -6. It could be it could be -6. But maybe it's not when x is 0. Maybe it's when x is 1/8, right? -1/8. We're not going to test those points. Right? We're just going to test the integer values and approximate. But when you're in calculus, you'll be able to calculate exactly where that turning point is. But for our purposes, this is close enough. So now we found our x-intercepts, we found our y-intercept, we made our sign chart, this is a sign chart, to find our relative extrema. Okay? And so now all that's left is we can identify a few key features like domain, all real numbers. Right? This is a polynomial. And this is cubic. Right? It's got 3 solutions. It's cubic. 3 distinct solutions, right? 1, 2, 3. 3 distinct solutions. It is a cubic function. Its range is all. And we can see from our graph, one end goes down to infinity, -infinity, and one end goes up to infinity. We can also analyze where we're above, where the function is positive and where the function is negative. So our function is positive from -3 to -2. Oops, that's supposed to be a parentheses, sorry. And then again from 1 to infinity, where it's above the x-axis. And then our function is negative, where it's below the x-axis. So that's from -infinity to -3. And then again from -3 to 1. So I'll put it over here. We can also analyze where it's increasing, decreasing. I think we'll save that for a different graph. It's increasing, right, where our y values are getting larger. Right? It's decreasing where our y values are getting smaller. Actually, maybe just to highlight the difference, we'll go over that. So the graph is increasing from -infinity to our turning point. Right? So we change from positive to negative or negative to positive at the x-intercepts. We change from increasing to decreasing at the turning points. So -infinity, and the x value on that was -5/2 is where we're increasing. And then we're decreasing from -5/2 to our turning point of, and that's where x is 0. And then after that, we're just increasing from 0 to infinity. And finally, we can look at end behavior. So f of x, our graph approaches -infinity as x approaches -infinity, right? As x is getting smaller, so is y, right? We're going down. And as x is getting larger, we're going up. So f of x approaches infinity as x approaches infinity. They're doing the same thing. They're both increasing together and decreasing. And boy, that's hard to read. So I'm just going to rewrite this really quickly, and that's the end of this video. That's a little better. Thanks for watching. Bye for now.